Wire fill capacity is directly related to the volume of the electrical box. When a box extension is added, the volume increases, which means more wire fill is permitted. To understand this, consider the formula wire fill equals box volume multiplied by allowable fill percentage. Let's say we start with an original box that is 4 inches by 1½ inches, resulting in a volume of 6 cubic inches. Now, we add a box extension of 1½ inches, which is 1.5 cubic inches. This gives us a total box volume with the extension of 7.5 cubic inches. Also, let's say that the allowable fill percentage for 9 number 12 wires in the original 4 inch by 1½ inch box is 40%. With this information, we can calculate the wire fill with the extension. Wire fill with extension equals 7.5 cubic inches multiplied by 40%, which gives us 3 cubic inches. Now let's compare the wire fill without the extension to the wire fill with the extension. The original wire fill without the extension was 6 cubic inches multiplied by 40%, which equals 2.4 cubic inches. With the extension, the wire fill is 3 cubic inches. Therefore, the box extension increases the wire fill capacity by 0.6 cubic inches. Now, to address whether 18 number 12 wires would be allowed. The National Electrical Code, or NEC, does not specifically say you can double the allowable wire fill percentage when you use a box extension. However, NEC Section 314.16 ATWO states that boxes shall be permitted to be filled to a maximum of 50% of their volume. Therefore, since the allowable fill percentage for the 4 inch by 1½ inch box with 9 number 12 wires is 40%, the total allowable fill would be 50%. In conclusion, adding a box extension does not allow for double the wire fill. Even with the increased volume of 7.5 cubic inches, you are limited to a total wire fill of 3 cubic inches. As a result, you would not be allowed to have 18 number 12 wires in the box. It's important to always consult the National Electrical Code and local regulations to ensure electrical work is performed safely and up to code. Understanding wire fill calculations and the limitations on box fill is crucial for preventing overheating, fire hazards, and other electrical problems. Remember that exceeding the allowable wire fill can lead to dangerous situations and is a violation of electrical codes. Always prioritize safety and adhere to the code requirements when working with electrical systems. These calculations are based on standard wire sizes and box dimensions. Always verify the specific requirements for your situation with the relevant codes and standards. The values used in this example are for illustrative purposes and may not be applicable to all situations. It is crucial to consult the NEC and local electrical codes for the specific requirements in your jurisdiction. Furthermore, consider the volume occupied by devices, such as switches and receptacles, when calculating box fill. These devices also contribute to the overall fill within the box. The NEC provides guidelines for calculating the volume occupied by these devices. Ensuring proper box fill is essential for the safe and reliable operation of electrical systems. Overfilled boxes can lead to overheating, insulation damage, and potential fire hazards. By following the NEC guidelines and performing accurate calculations, you can avoid these risks and ensure that your electrical installations are safe and compliant. In addition to the volume of the conductors and devices, consider the impact of cable clamps, support fittings, and other hardware on the overall box fill. These items can take up valuable space within the box and should be factored into your calculations. When using metal boxes, ensure that all bonding jumpers are properly sized and installed to maintain electrical continuity. These bonding jumpers also contribute to the overall fill within the box and should be considered in your calculations. Always use the appropriate tools and equipment when working with electrical systems. This includes wire strippers, crimpers, and other specialized tools that are designed to ensure safe and reliable connections. When in doubt, consult with a qualified electrician to ensure that your electrical work is performed safely and up to code. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. Regularly review the NEC and local electrical codes to ensure that your work is compliant and safe. By following these guidelines and taking the necessary precautions, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and standards. Also, always double-check your calculations and measurements to avoid errors. Even small errors can have significant consequences when it comes to electrical work. Taking the time to verify your work can help prevent mistakes and ensure that your installations are safe and reliable. Consider the environmental conditions when selecting electrical boxes and fittings. For example, if you are working in a damp or wet location, you will need to use boxes and fittings that are rated for wet locations. These boxes and fittings are designed to protect the electrical connections from moisture and corrosion. When installing electrical boxes, be sure to properly support them to prevent them from sagging or shifting over time. This is especially important for boxes that are mounted on ceilings or walls. Use appropriate mounting hardware and techniques to ensure that the boxes are securely supported. In addition to the NEC, there may be other local codes and regulations that apply to electrical work in your area. Be sure to check with your local authorities to determine the specific requirements for your location. Always disconnect power before working on any electrical circuits. This is the most important safety precaution you can take to prevent electrical shock and injury. Use a voltage tester to verify that the power is off before you begin working. Wear appropriate personal protective equipment, such as safety glasses and gloves when working with electrical systems. This will help protect you from potential hazards such as electrical shock, arc flash, and flying debris. Never work on electrical systems when you are tired or distracted. It is important to be alert and focused when working with electricity to avoid making mistakes. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to do the job safely. Regularly inspect your electrical systems for any signs of damage or wear. This includes checking for loose wires, cracked insulation, and corroded connections. If you find any problems, have them repaired by a qualified electrician as soon as possible. Consider using surge protectors to protect your electronic equipment from power surges. Power surges can damage or destroy sensitive electronic equipment, so it is important to take steps to protect them. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat and potentially start a fire. Be sure to use the appropriate size circuit breaker or fuse for each circuit. Do not run extension cords across walkways or under rugs. Extension cords can be a tripping hazard, and they can also overheat if they are covered. If you need to run an extension cord, be sure to use a heavy-duty cord and route it safely. Keep electrical outlets and switches clean and free of dust and debris. Dust and debris can accumulate in electrical outlets and switches, which can create a fire hazard. Regularly clean your electrical outlets and switches with a vacuum cleaner or a soft cloth. Teach children about electrical safety. Children should be taught not to play with electrical outlets, cords, or appliances. They should also be taught what to do in case of an electrical emergency. Have a fire extinguisher readily available in case of an electrical fire. Be sure to use a fire extinguisher that is rated for electrical fires. If you have any questions about electrical safety, contact a qualified electrician or your local fire department. They can provide you with valuable information and guidance on how to stay safe around electricity. Regularly test your ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect you from electrical shock by quickly shutting off the power to a circuit if a ground fault is detected. Test your GFCIs monthly to ensure that they are working properly. If a GFCI trips frequently, there may be a problem with the circuit. Have a qualified electrician inspect the circuit to determine the cause of the tripping. Do not use electrical appliances near water. Water is a conductor of electricity, so using electrical appliances near water can create a serious shock hazard. Keep electrical appliances away from sinks, bathtubs, and other sources of water. If an electrical appliance falls into water, do not touch it. Immediately disconnect the power to the circuit breaker or fuse box. Then, you can safely remove the appliance from the water. Be careful when using ladders around electrical power lines. Ladders can conduct electricity, so it is important to be aware of the location of overhead power lines when using a ladder. Keep ladders at least 10 feet away from power lines. If you need to work near power lines, contact your local utility company to have the power lines de-energized. Be aware of the location of underground electrical cables before you dig. Digging into an underground electrical cable can be extremely dangerous. Before you dig, contact your local utility company to have them mark the location of underground cables. If you accidentally damage an underground electrical cable, evacuate the area immediately and call 911. Do not attempt to repair the cable yourself. Be cautious when working with aluminum wiring. Aluminum wiring was commonly used in homes built in the 1960s and 1970s. Aluminum wiring can be a fire hazard if it is not properly installed and maintained. If you have aluminum wiring in your home, have it inspected by a qualified electrician. Consider upgrading your electrical panel if it is old or outdated. Old or outdated electrical panels may not be able to handle the electrical demands of modern homes. Upgrading your electrical panel can improve the safety and reliability of your electrical system. When adding new electrical circuits, be sure to use the appropriate size wire. Using undersized wire can cause the wire to overheat and potentially start a fire. Consult the NEC to determine the correct wire size for each circuit. Use caution when working with energized electrical equipment. Energized electrical equipment can be extremely dangerous. Only qualified personnel should work on energized electrical equipment. Always follow safe work practices and use appropriate personal protective equipment when working with energized equipment. Remember that electrical safety is everyone's responsibility. By following these safety tips, you can help prevent electrical accidents and injuries. It's crucial to understand how different types of conductors, such as solid and stranded, affect box fill calculations. Solid conductors generally take up more space than stranded conductors of the same gauge. Therefore, when calculating box fill, it's essential to consider the type of conductors being used. Additionally, be aware of the different types of box connectors and their impact on box fill. Some connectors are more compact than others and can help maximize the available space within the box. When selecting box connectors, choose those that are appropriate for the type of conductors being used and that minimize the amount of space they occupy within the box. It's also important to consider the grounding requirements for electrical boxes. Metal boxes must be grounded to ensure electrical safety. The grounding conductor must be properly sized and connected to the box in accordance with the NEC. When calculating box fill, be sure to account for the space occupied by the grounding conductor and any associated hardware. Remember that the NEC provides specific guidelines for calculating box fill, and it's essential to follow these guidelines to ensure compliance and safety. Consult the NEC for detailed information on box fill calculations and requirements. Also, consider the use of cable ties or other means of securing conductors within the box. Properly securing conductors can help prevent them from becoming tangled or damaged and can also make it easier to access the conductors for future maintenance or repairs. When using cable ties, be sure to use those that are approved for electrical use and that are resistant to heat and moisture. In addition to the volume of the conductors and devices, consider the impact of any splices or taps that are made within the box. Splices and taps take up space within the box and must be factored into your calculations. Use approved splicing methods and materials to ensure safe and reliable connections. When making splices or taps, be sure to leave enough slack in the conductors to allow for future maintenance or repairs. It's also important to consider the type of enclosure being used. Different types of enclosures have different fill capacities, and it's essential to select an enclosure that is appropriate for the application. For example, enclosures that are used in wet or damp locations must be rated for those environments and must have a higher fill capacity than enclosures that are used in dry locations. Remember that the NEC provides specific guidelines for selecting enclosures and calculating their fill capacity. Consult the NEC for detailed information on enclosure requirements. Also, consider the use of wire markers or labels to identify the different conductors within the box. Wire markers or labels can help prevent confusion and make it easier to troubleshoot electrical problems in the future. When using wire markers or labels, be sure to use those that are durable and resistant to fading or smudging. In addition to the NEC, there may be other industry standards or best practices that apply to electrical work in your area. Be sure to familiarize yourself with these standards and practices and follow them when performing electrical work. Remember that electrical safety is an ongoing process, and it's essential to stay up to date on the latest codes, standards, and best practices. By following these guidelines and taking the necessary precautions, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable requirements.